All right, we're going to start with the vocabulary. We actually kept struggling whether you first start with the data and then you explain how the vocabulary works, or you first do the vocabulary but then you don't know how the data work that the vocabulary represent. There is no perfect solution. It's a chicken and egg thing. So there are going to be moments where we're going to say, you know, hold the thought, and you're going to see it later on. Okay? So just starting with the representation of the data in the data model. And the data model is built in such a way that with few exceptions, which we're going to point out, the data contains nothing verbatim. Everything is coded. Okay? Everything is coded. Quick. So you need to know how you find these codes and how these codes work and where they're coming from and how do they relate to each other and how do you operate this, right? And so that's what this is. OHDSI provides, well, when we get there, I'm going to explain that. As I said before, OHDSI is very lazy. So if we can, we will not create our own reference tables. We're going to import them from other people who know what they're doing and have been doing it for a long time. Okay? And we prefer the public ones over the proprietary ones, but there are also some proprietary ones in there. And then we compile them together, so you have one way to access them. So you don't need to know how ICD-9 looks like and how SNOMED looks like and SNOMED Australia looks like and all these kind of things. All that stuff is done for you. Okay? It changes because there are constantly releases. I mean, there is not only are there new drugs and that kind of obvious stuff, but they also change things and they take out deduplications and they are bad codes and then they split them up. So there's always a little bit of churn. Most of it, though, doesn't. So the OMOP experiment we could run today with today's vocabulary practically without any change. Not because if it's static, but because 90% of it is de facto static because it's just good and set. So that's why when people get very, at the beginning when they start doing this, they get very nervous. What's my version that I have of the vocabulary? And I don't have the August one, I have only the July one. Almost everything is the same, which is why the actual experiments don't care. Okay? But there will be changes at the fringes, and it's good to know why they are and how that happens. But the first approximation is it actually stays the same. Okay? And it never will finish. So if you find issues, don't just sit there and get grumpy. So it's not finished and it's not without mistakes. So if you find something that looks like funny, don't hesitate to put a forum post into the forum. Don't think you look silly because maybe that was just you don't understand. It doesn't matter. We're going to explain it over and over again if it was a mistake. And if there's really a problem, then it's good to know. Because the only way to find out, you can't, I mean, as much as you do QA, the only way to find out if there's problem with the content is if people actually say when they bump into it. Okay? So no bashfulness at all. Please, if you have a problem or you see something looks fishy, bring it on. Okay? There is a database model behind the vocabulary. Actually, it's very simple. You really only need to know 3 tables. 3. Concept, concept relationship, and concept ancestor. And we're going to work extensively with you to make you familiar with them. Okay. We're going to use a study that the FDA did in the MiniSentinel program a couple of days ago. And what they did is this is the paper that they wrote in the New England Journal of Medicine. And what they did is they compared a new drug called Dabigatran to an old drug, warfarin, to see whether or not one has more of a side effect than the other. And the side effect is bleeding into the upper gastrointestinal tract. So both of them are blood thinners. So the fact that you bleed isn't completely unexpected. The question is, how much do these drugs cause that? Upper gastrointestinal bleeding means you bleed anywhere from the mouth to the duodenum, because when you do that, the blood comes out this way through the mouth. If you bleed into the lower gastrointestinal tract, the blood comes out the other way. So it's just a clinical concept called upper gastrointestinal bleeding, because the symptoms is always the same. You know, red blood comes, you vomit red blood. Pretty impressive. And so what they did is they took, well, they also did intracranial hemorrhage. We're not going to worry about that. We're only going to worry about the gastrointestinal hemorrhage. Hemorrhage and bleeding is the same thing. It's a synonym. And so what they did is they looked at patients who take the drugs for atrial fibrillation, and either the one or the other, and then they see how many of them per 100,000 days at risk bleed in Dabigatran, and how many of them bleed in warfarin. And the reason they do the study is there were a spontaneous report that said, oh my God, this new drug, people bleed a lot more. And so they found out it doesn't look like this. The paper itself has a lot of mechanical flaws, and they got bad comments in the New England Journal of Medicine and other places, and other people wrote papers about the same thing and said this is a bad paper. But anyway, for our purpose, it's very good because it's public. The FDA did it, and it has everything you need in order to run a simple study with no adjustment for bias or anything like this. Just compare the people who take one with the people who take the other. How many of them do they bleed? So at the end of the day, you can run this study, okay, yourself on this little thing, this little database in your VM. Okay. So now we get into the actually detail. Everything in the OMOP common data model has a concept. So if you have a drug, or you have a condition, upper gastrointestinal bleeding or atrial fibrillation, there is a concept for that. There's one reference table for all concepts. It's called concept. That's the table. So if you want to look into this reference table, and for example, you pick out the record which has concept ID equal to 313217, and you can do that as you go, or I'm going to do it on the screen as a screenshot, you're going to get this record back. Okay? This is atrial fibrillation. It's a condition of the heart where the upper, smaller chamber stop beating in a rhythmical way. It's fine, you still can live with that because the main heart chamber will still beat with a normal pulse. And this one is just going to go like very, very quick movements, and it doesn't actually transport much of the blood, or doesn't contribute much to the transportation of the blood. The problem is not that the blood doesn't get pumped. It does by the main chamber, otherwise you would be dead. The problem is that the flow of blood in an atrial fibrillation is no longer smooth, and it becomes turbulent. And if you have turbulent blood flow, it clots. That's how blood works. That's why these patients have to have blood thinning so it doesn't clot. Because if it clots, the clot goes from the blood into the brain and gives you a stroke, or into the lung and gives you an infarction in the lung or into the leg, and so on and so on. So you get a thrombotic event. Okay? So people get these blood thinners, so the blood doesn't clot in the atrium. And usually these are older generations, and they have to be on this medication for a long time. And the old medication, warfarin, that we've compared to, you have to very titrate that you don't give it too much. If you give it too much, people start bleeding. If you don't give it enough, the blood thinning effect doesn't care. So there are all these old ladies, they have to go and check out their clotting all the time, and then they get this exact dose adjustment. And it's very hard, and they forget it, and so it's a problem. So the new drug, Dabigatran, was very good because you take it once a day and you're good. It just lowers the blood clotting a little bit, not too much, and it was exactly what was needed just for those kind of patients in particular. Okay, so that's what the whole situation is that we are talking here. All these different. So you have we have one reference table for everything, which means all these different databases and vocabularies and their different formats are all now in the same representation. But they aren't when they come, right? This is LOINC. When you download LOINC, the multi-actual hierarchy, it looks like this. And the LOINC code is called code. Okay, that's a LOINC code. Okay, if you download LOINC CSV, which is the actual reference table, so LOINC CSV is the reference table. This is a hierarchy table. Okay, then the LOINC code is called LOINC number. Okay, so all of them are completely idiosyncratic. This is even within the same organization. They call the same thing different in different tables. Okay, it's always different. If you ICDs, here's an example for ICDs. This is ICD-9, by the way. No way you can guess that. But it's called iDiagnosis code. Has no dot in it, even though it's supposed to have a dot in it. So all these vocabularies, and people who know vocabularies and download them and try to put them in their systems, it's always a new job. This is over. You're going to have one concept table, and all the vocabularies which are in there look exactly the same. Because the little, the people that, who do this in the vocabulary team, like Dima is one of them, or he's actually the one who runs it, they do the work of incorporating all these vocabularies so they fit into the concept table. And the concept table is very simple. Actually, there's a slide gone. There was a slide which showed us the concept table. Concept record. Okay, so let's look at the condition, how these vocabularies now work. So we have several vocabularies which give us conditions. Conditions are diagnostic codes or signs or symptoms. Okay. So anything that you have which is a condition of a disease at various different levels of levels of how much it's corroborated and understood and diagnosed. So your source data, they have any of these different coding systems, right? ICD-9-CM in the US, ICD-10-CM in the US. In the US, by the way, it's not ICD-10 or ICD-9. It's ICD-9-CM and ICD-9-10-CM. We have to pay a lot of attention here because there is actually the real ICD-10, which is made by the World Health Organization. And it contains 17,000 concepts, while the American one contains 70,000 concepts. So they just blew it up by a factor of 4 more concepts. The ones which are in ICD-10 are also in ICD-10-CM, well, almost all of them, because every country does their own little national version, just because they can. Of course, it's awful, because then it's difficult to compare. So they drop a few things, they add a few things, they even change a little bit of the ones that already are there. So when we talk ICD-9 on ICD-10, it's always ICD-9-CM and ICD-10-CM, and it stands for clinical modification, I think. And the CMS, Center for Medicaid and Medicaid Services, produce them. These are the source codes. Everything which is under the bar are the source codes. This is what your data comes with. Or sometimes the data come without any codes, just verbatim text, right? The doctor types something in. But many of them are coded. And so this is in England, and this is in England, and so on. They're getting more and more and more of those. And then they get mapped into what we consider standard concepts, which means these are the ones that represent the fact. Because all of these guys have an atrial fibrillation and a gastrointestinal bleeding and a myocardial infarction and a nausea. Okay, so you have the same thing many times over. So if you want to have a standardized, harmonized way to represent atrial fibrillation, you have to pick one of these guys to be more equal than the others. And that's what we call standard concepts. And for conditions, we picked SNOMED as to be the one which is the standard. But it could be anything. You could have a mixture of things, right? So the one which is standard is the one which is allowed to represent the meaning. And these guys get mapped into it, okay? You don't have to do the mapping. We give you the mapping. You'll see that in a second, right? So the read atrial fibrillation is going to be mapped into the SNOMED atrial fibrillation, and that's the one which goes in the data, okay? So that you can ask one question every database, and the question is always the same, and the answer is correct. Question?
The mapping of these lower level coding systems to SNOMED, is that standardized across the world, or is this something that OMOP and OHDSI have to deal with on an individual coding system basis?
So the question is, are these maps universally agreed upon, or is that something that OHDSI is doing? No, they're not. OHDSI has to do it. So they are. So we steal. UMLS is a very good starting point to steal a lot of that information. But they only map what's equivalent. They don't map things which aren't quite equivalent. And they don't have all the vocabularies that we need. And of course, if you want to do UMLS, you have to do a little PhD program to figure out how UMLS works. But no, so there is no generally accepted, worldwide. We all agree that atrial fibrillation is atrial fibrillation. Here it's simple, but sometimes it's not exactly the same meaning, and then you have choices. John?
Is SNOMED the most granular? In terms of, for example, I don't see the MEDRA low-level terms being mapped anywhere.
Yeah, so the question is SNOMED the most granular, and then why are the low-level terms not mapped? So let me actually explain the classification real quick. So these are the standard concepts, and these are classification concepts which sit on top of the standard concepts, and they don't participate in the data. You cannot have a MEDRA term concept in the data, but the vocabulary has them linked up in a hierarchical system, which you're going to learn in a second, okay? So then you can ask, give me everything which is a child of this MEDRA, and it gives you the SNOMED concepts, and those you can use to query, okay? So it's similar to the mapping. The difference is the mappings, the source codes, get mapped into SNOMED and then thrown away. We don't want to see them anymore. While the classifications are classifications particularly useful in domains where the standard concepts aren't already hierarchical. In this case, we have two hierarchies on top of each other. It's kind of funny. But in drugs, you'll see it's different. And there you need classifications to classify your drugs, right? For example, blood thinners, okay? You'll see that, okay? So, and yes, SNOMED is probably by far the most granular with the most rich hierarchy. And they also try to do a whole lot of things they try to do right. It's not perfect. They have mistakes. Not mistakes, but things where you're saying, wait, this shouldn't be, related that way. But it's a lot better than most other things. The reason to pick SNOMED is because it was made for analytic use cases. These guys are made for reporting of mortality and reimbursement. Okay, so there's a lot of stuff which for analyzing what's going on with patients is completely useless because it's for the insurance company to decide whether or not they should pay. It has nothing to do with what's going on with the patient. But they need that. And so, so now we have the ICDs in the world. They also come with a little hierarchy, but the hierarchy is very primitive and it allows only one parent for each concept, which is a problem, right? If you have tuberculosis of the lung, your parents are tuberculosis and lung disease. In ICD, it can be only one of the two. You have to pick one parent, even though you have 2 or 10. Yes?
I have a question about maybe source codes for the inpatient setting. If I'm going, and I don't know if it exists or not, if I'm going after something like a SOFA score or vasopressor, which is a drip from the EHR on one of these flow sheets, are there concepts or source codes that you can crosswalk down to like time series variant of drips or vitals or something like that? Is that part of this? Or?
Yes, all clinical concepts potentially have a representation here. And if they don't, and they're needed, we add them. So everything goes in there. So right now we are just talking about conditions, which are like, these diagnostic codes, mostly, and symptoms. But all sorts of other things can go in there too. And my most favorite concept of all, of course, is a read concept called brother in prison. And it does have an effect on, the state of, the health state of or it may have an effect on the state of the health of a person. But we have those things in here. So potentially you can, if it has a use case for doing analytical work of this kind, we would have no reason not to bring it in. Yes?
I have a question about a gap area, and NIH and the FDA are in the process of working for patient-reported outcomes or clinical outcome assessments in FDA language to be accepted as drug development tools. And these are standardized and validated, and where would they fit in to this? How could we start incorporating them, because they will be on the label?
Yeah, so the question is, where do patient-reported outcomes go in here? So there's a whole working group working on that, on surveys and patient-reported outcomes to bring them in and to have a way to, and what the domain would entail and what you need. It's more than just a condition, right? Because you have to give a little bit more extra information around it. There's a working group. Actually, MUI is on it, and to deal with that. And then, of course, the question is, if the patient says, I have atrial fibrillation, will that automatically cause a record in the condition table? Because otherwise, you have to look in all sorts of different places. Is it here, maybe here, maybe here? And that's not what we want to do. If it's a condition, you look in one place and nowhere else. If it's not there, it didn't happen. Okay. So now, last question from John, why is low-level terms not mapped? That's just laziness, because there's so many, okay? And they're very similar to the preferred terms. There's not a lot of difference to them. So we say, can you just give us a preferred term? But, if there's a good use case and there is money on the table, that would help a lot. That could be fixed. But it's a completely pragmatic decision. So now the question is, how do you find them? So we know that the concept is the thing which tells you the patient had atrial fibrillation, or bleeding, or a drug, or patient-reported outcome. How do we find them? We need to find them in the reference table, right? How do we do that? And you're gonna have to do that all the time, because if you want to query the data, you're gonna have to find the patient you want to query the data for. So there's no way around. The data will not contain the word bleeding, okay? It will not. It will only contain these concept IDs. And they are completely meaningless, right? So ICDs, they try to put some logic into how they make the codes, right? No logic, the numbers are completely all over the place. They mean nothing, okay? So how do you find them? If you know the concept ID, then you just pull it up. So there are 5,700,000 concepts. If you know them all, then you're done. You don't have to sit in the class anymore. You know how to find it. Okay? But you probably don't. So, but if you do, for example, I, now having given this tutorial for a while, know that 313217 is atrial fibrillation. I can type it in, and I get the record. Right? This is atrial fibrillation. It's a SNOMED code, because we use, for conditions, we use SNOMED. Again, that's an arbitrary pragmatic choice. Doesn't have to be the way, but it is. It's a standard concept, which means it goes into the database of patient records. The patient records will only contain the S concepts. Don't try to find a concept which is not an S, like a source concept. This is this concept code. I'll show you what that is in the middle, in a moment. And then there is this life cycle stuff, right? From when to when, which means when was a concept active. And since we're all doing longitudinal databases here and the past, we can't fix the past. And they gave us codes that were correct in the past and no longer are correct. We need to be able to catch this, right? 1st of January 1970, that's kind of like Unix notation for the beginning of the world, which means it always was there. We don't know when it came into being. It was always there. Okay, and 21st of December 2099 means it's valid. The invalid date is way in the future, and probably none of us will get to the moment when the whole OMOP Common Data Model will break down, because it's the 1st of January 2100. So let those people figure out what to do when they get to that. Not going to be our problem. Now, if you know the code, and the code is 494360004. If you know the code, and the code actually has to be in quotes because it's an alphanumeric one. This thing is a numeric one. All the concept IDs are numeric, just so it's faster, the databases. This is alphanumeric. If you know the code, then you find it too. So what the hell is a code and what is an ID? And why do we need both? Okay. Well, 494360004 is what SNOMED calls it. And by the way, they call it concept ID just to screw everything up a little. IDs are the things that we call, and codes are the things they call. So everything with a source code is them. Okay. Concept ID is us. So ID is everything OMOP. Code is everything what the other guys did, even though they call it ID. But we know better. It's a code. Right? If you go into one of these public servers, SNOMED browsers, and there are lots of them, and some of them are actually very good, and you type in atrial fibrillation, it pulls it up and gives you the code. And they call it concept ID, just to confuse you. But that's that one. So that's their way to refer to it. We call it 313217. They call it 494360004. Okay. So we have in the database, in the concept table, our identifier and their identifier. Why the hell do we do that? If they already have a code, why give them another code? Okay. Because they don't talk to each other, and the same code will be in several different vocabularies. So for example, if you ask, give me everything which is 001, you're going to get a whole lot of different records back. Some of them, this is a drug, this is a drug, this is a whole mixture of different things, drug, revenue code. All of them are 1001 in those databases. So if we didn't, so that's why every concept has to be given a new name, kind of like the Pope when he gets elected. He was Mario and now he is Francis, so that there is a unique identifier for every Pope, okay, Francis I. And same thing here. There are all these Marios and they are not unique across the databases. And so the same thing is, and so we give them a new ID such that there is one identifier for everything across all the different 57 vocabularies that are in the system. It sucks, but there's nothing we can do about it. Okay? So we give them different codes. So if you talk to people outside the OMOP world, which gets getting smaller and smaller, then, and they're saying, what SNOMED code are you using? You have to pull up the concept code because they have no idea what the concept ID is, because they've never seen that thing. Okay? But they very clearly know what this 46436.004 is. Okay? Question?
So, is my understanding right that each of these codes would have its own concept names, like ABC codes would have their concept names, Hripcsak and CPT codes would have their concept names?
Concept name, yes. So every concept has a concept name, and we just import. So the question is, has every different vocabulary their own concept name? And yes, we just import them. Whatever they call it, that's what it is.
So the source codes that you had previously listed on the slide do not comprise NDC codes or Hripcsak or CPT
Yeah. So there's an Hripcsak. So all of Hripcsak is in here with the concept name that they gave it.
And would they be referenced across? So if you were to search atrial fibrillation,
Yeah, you'll see that in a minute.
you have the
Hold the thought. Hold the thought. We're going to get there. If you know the name, here you go. Perfect segue. If you know the name, and this is usually what you do, right? You don't know the code and you don't know the ID. You know the name. You don't need to know. You need to find patients with atrial fibrillation. That's what you need to do, right? That's when you go to work and you start the study. That's what's happening, right? So you type in atrial fibrillation, trying to be very lucky that the spelling is going to be exactly the spelling that you're going to find. And actually, you got lucky. And you got the atrial fibrillation, except you got 5. Why did you get 5? Because they all have an atrial fibrillation, right? You have one in SNOMED, that's our friend. You have one in ICD-9-CM. You have one in MEDRA. You have one in READ. You have one in LOINC. So now what? Which one is the right one? The right one is the one with the S as the standard concept. The others are not quite as equal as this one. Okay? There are 2 S's. Okay? How can that be if there's only one representing atrial fibrillation? This one is not a condition. It's actually a measurement. It's actually a measurement value, which means it's a lab test. So in this case, actually it is, because many of these, that goes to your question, right now, many of the surveys and patient-reported stuff is in LOINC, and so this is in answers. But and we're gonna take it out there, okay? But this is but it will show up too, because there's a question: what prior conditions do you have? And the answer is atrial fibrillation. Okay, so it's not a condition. So it is an S, but in the measurement table, and not in the condition table. So we are looking for a condition. We're looking for an S, and there's only one, and there will be only one. Even SNOMED sometimes have duplicates, and we pick one of them. Okay, so you should find the one concept that you need. Only one. Okay, that's actually a good thing, because that makes it interoperable. Because then I can ask a question. I can ask the same question in Australia or in Germany, and I get the patients back with atrial fibrillation, no matter what the original source code, was, or maybe even without a source code like the French, no source codes at all. Question is, why are the concept IDs different for these values?
I understand what a concept code is, because that's the underlying code for the different sources.
Because it's a unique identifier. So the ICD-9-CM atrial fibrillation, this one, is a different concept because the vocabulary is ICD-9-CM and not SNOMED. So it's a different concept. We're going to learn how you get from one to the other. Obviously, you want to do that, right? You want to know if I do have the wrong one, how do I get the right one? It'll all do that for you. It's going to help you. Mm-hmm. Say again? C. What the question is, what's the C? That's a classification concept. So MEDRA is a classification concept. Again, can't find it in the data, but you can use it as a magnet to pull out the data, because it's going to have a hierarchical relationship. You're going to see that. It's very elegant. It's going to have hierarchical relationships to the S's. These guys don't have a hierarchical relationships to the S's. They just get mapped. Okay? You'll see that. Don't worry yet. You'll see that, how it works.
So, I have a question.
Yeah.
So, in the domain standard concept, there's either going to be an S or a C, right? Those are only two values?
Right. Or null. So the only in the standard concept, you can either have a null, which people say, why the hell did you do a null? It's not fast. But okay, it's too late now. Null means it's a source code. It doesn't participate in the data, and you can't use it in a hierarchy to find the one which participate in the data. Okay, so that's S and C. These are the ones which you want to get away from. You're going to see how you get away from them. The vocabulary gives you everything you need in order to get away from it. Okay. Now, this is your question. What if you know, and this is also very typical, if you know the code, but it's not a SNOMED code. You know an ICD-9 code. Many people know ICD-9 codes by heart. It's embarrassing, but they do. And the ICD-9 code for atrial fibrillation is 427.31. And if you pull this thing up, and we know we have to pull it up in the code, not in the ID, because it's their way to call this thing. It's a Mario. Okay. If you put it in the code, you're going to get that thing. Here it is, and it's the one that we just talked about. It's an ICD-9 CM, 5-digit billing code. Billing means you can, bill for it. And this is the concept code. And that's what we got, the concept ID we gave it. Completely meaningless number. It's an atrial fibrillation. Good, right? No, it's not good. You're not going to find a single patient with that code. Not one. Even in the US database. Because it's not a standard concept. You need to be able to translate this thing from the source to the standard, which we know is a SNOMED, and the number is 313217. How do we do that? There is a concept relationship table. The concept relationship table contains all the relationships that concept have amongst each other. And one of the relationships that concept can have to each other is a mapping relationship. And the relationship ID is called maps2. Makes it very simple. So if you pull up in your little SQL screen, the query select star from concept relationship, where concept ID 1 is this guy, not the concept code, concept ID, everything is ID. We called it this way, otherwise it's ambiguous. Then you're going to get records from the concept relationship table. And the concept relationship table is very simple. Concept 1, concept 2, how are they related? And then you have the validity stuff, whether it's valid or not. Okay, so don't worry about it now. Right now we're only talking about valid ones at this point. Right? Concept 1 is related to concept 2 this way. And since we set the concept 1, it gives us all the relationships this concept has. And the concept has the relationship ICD-9 CM to FDB indication, ICD-9 CM to MEDRA, is a hierarchical, and maps 2. And that's the one we want right now. We're going to talk about the other relationships too. We want this one. And this one maps this ICD-9 concept, ICD-9 CM concept, sorry, to the standard SNOMED concept. See, 313217, that's our friendo. So the OMOP vocabulary gives you the mapping for free, downloadable from the web. You don't have to go and start your own mapping and to do all sorts of stress in order. How do I get from ICD-9 to SNOMED? It's there. Every ICD-9 code has, or concept, has a map. Not all. There are a few of them that are so crazy that there's no way to map to anything. But almost all of them have a map. Okay? Why do we do this? This is crazy. Why do we have to go through the whole exercise of mapping all these codes? And who knows whether these maps are good? And I don't know. And can I trust this? And can I rely on the data? And if I rely on data, then I have to rely that OHDSI does these mapping tables right. And how do I know that the mapping tables are right? I mean, oh, these guys, So here's the reason why, and I give a little example to explain why this is a good idea, not a bad idea. So the European Union, if you Commission, which is essentially the kind of a government institution, on the website is very proud, explaining how it works with all the different languages. There are 24 official languages of the European Union, all of these countries, big and small. These are the 24. And how do they make it work? They very proudly explain there's a permanent staff of 1,750 linguists, 1,700 linguists, 600 support staff. The Commission has one of the largest translation servers in the world, very proud about that too, bolstered by a further 600 full-time and 3,000 freelance interpreters. So you have a whole town, just translators, okay? And the way that works is when the Commission is in session, then somebody is going to the podium and speaks in their native language, and in the back, you have 24 of them sitting, doing simultaneous translation, and the other guys are sitting with a headset and listening, okay? The next one comes up, gives a speech, all of them in the little booths go, and the next session comes in so that they can now translate from Hungarian to French and to German and to English and to Spanish, okay? So that's how it works. And it's a gigantic system, and when the session is over and they go to the bar or they go to, or they have a hearing, what do? They all speak English, okay? All speak English. And that's what we do. Why have all these crazinesses of different codings of the same thing if you could have one way to represent the same thing, okay? Because then you can ask the question, or you can say cheers, okay? And you don't have to say any of these other things and know what they all mean, okay? Because it's the same meaning, and you have one way to represent the meaning, and then your communication will become incredibly more efficient, and you enable, essentially it's a core of enabling of this stuff being entirely interoperable, because you can find the meaning in one way. Just ask the question in English or in SNOMED standard concept speak, okay? That's what it essentially is. So the mapping table, which is not a separate table, it's part of the concept relationship table, is essentially a translator. It's a dictionary. Well, these dictionaries all die, so some people will still remember them. Now it's called translate.google.com. But those of us who still remember those days, we had to actually page through paper. That's what it is, right? You find the source concept. It's alphabetically in the dictionary. We have a database, you don't have to worry about that. And then we find the translation in the dictionary where the relationship ID is maps to, and then it gives us the answer. And that works for them all, and you don't have to worry about it. So OMOP gives you all the dictionaries, okay? You download it from Athena, and you got all that information. Yes, questions?
In the concept ID 1, can the concept ID 1 and concept ID have different,
Yes.
can they be different?
So yes, the question is does it matter whether it's concept ID 1 and concept ID 2?
No, 1 and that ID.
So
Concept ID 1 and the concept ID from the concept table.
well, this is,
Yes.
yes, so if you want to translate this guy in yellow, you ask the table, the concept relationship table, for this concept ID, because it's H of, and then it gives you the translate. So this is, essentially the word representations, right? This is Skål, and this is cheers, except we use these numbers, right?
Okay, so you use the maps too instead of, so,
Yes,
sorry again,
maps.
can you say what is A is?
We'll get to the other concepts in a sec. We'll get them in detail, okay? And then the question that also often comes up, does it matter which one is which? The entire relationship table is in there twice, flipped over. So if you look 4482.195 in concept ID 2, you find a record which will put this in concept ID 1, except now it's not called maps to, but it's called mapped from. So the entire concept relationship, otherwise you have to each time try this one or that one because you don't know whether it's a destination or a source. You don't have to worry about it. Always use one, or always use two. Doesn't matter. Okay. Another question somewhere here? No. Yes, Shunwa.
I saw you have 58 relationships in the relationship table. How do you determine when to add a new relation?
So the question is, where do we get these relationships from, and how do we add relationships? Yeah. That's not an exact science. If there is a relationship ID already in there that we can use, and the meaning is the meaning, we use it, but sometimes there are some of them in parallel which are kind of similar to each other. But again, the important ones are simple and they are standardized and like maps to. And we're going to talk about the other, or is A is another one. It works everywhere the same way. And we're going to show you what they look like. But there's some exotic ones, like for example, ICD9 to Medra. It's actually we probably should kick it out because it just confuses people. Because neither of them are standard, and it shouldn't be there. But it's like one of these exotic ones, and they're just in there, so they get their own map relationship ID. Yeah. So yeah, and the other thing is, of course, people complain about them being slow in a database because they are text and not numbers. Okay. Gowtham.
If you had multiple
Chandra.
ICD-9 CM codes for the same concept name, would you see each of these ICD-9 CM as a separate row?
Can you do that? You can have several names in ICD9 which is the same but have different codes?
The specificity, if you're looking at the broader, the upper level term for the ICD-9 code, and then get specific, would it go under the same concept name?
No, they're all different. Every ICD9 code has their own concept. So if you have a broader one, so if you have one here which is 427 without 31, well, that's a different one. 427 is its own. 4.7.3 is its own. They're all their own.
So you would go by 5-digit, 4-digit,
The way, whichever way you are used to find the ICD9 codes, you can use here too. But each of the ICD9 codes has a record in the concept table, their own one record in the concept table, and each of them has their own mapping to SNOMED.
And then would they have their own mapping to ICD-10 CM as well?
No, there's no mapping between, the question is whether are there map between ICD9 and ICD-10. There's no mapping between source codes. Everything goes to English, no Swedish to Hungarian, okay? Everything goes to English.
But why did you when you did the query, why did you show the ICD-10 mapping when you did the relationship query? You only showed the ICD-9 to the...
So the question is, why is there only the ICD-9 to SNOMED mapping and not the ICD-10 to SNOMED mapping? Correct? Well, because we picked up an ICD-9 code. If you're asking for an ICD-9 code, you get an ICD-9 code, and you get to map this ICD-9 code. If you can get an ICD-10, you're going to do an exercise in a minute and do that, actually. So you're going to warm up for that. Here it is. That's called a segue, a paid segue. Okay. So please do it. Okay. So this is the ICD-9 code we just did. Well, maybe I shouldn't say that because you may have already forgot. There's a read code. There's an ICD-10 code. Find the concept and then map the concept. Okay, so go in the database. Concepts, the concept codes in the concept table are called concept code. And then it gives you a concept, and then you take this concept ID to go into the mapping table. Because the mapping table doesn't work off of the concept codes because the concept codes are not unique. 427.31 can be a code in another vocabulary. It's not a unique thing. That's why we need to use the mapping IDs, the concept IDs. No cheating. Yeah, don't cheat yet. You have a little sequel. You have a cheat sheet where all the correct sequels are in. Try not to use it. Wow. We can't find the read code. Okay. Can't find the read code. Somebody uploaded a vocabulary without read in it.
That was on purpose, though, because if you
Yes,
don't select
we did it on purpose.
If you don't select Athenic, for instance.
If somebody didn't click on read, okay, somebody whose name starts with a K didn't click on read. So if you can't find read, don't worry about it. Another question was, is maps to always mapping to a standard concept? And the answer is yes. Maps to always maps to a standard concept. You don't have to worry about it. Whatever maps to is what you need. They even map to themselves if they already are a standard. So if you have a SNOMED and you're saying, what does it map to? It will map to itself.
Is there a reason for making the concept names case?
Next question is case sensitivity of concept names. We don't change the cases, okay? So whatever the source gives us is in there. And they do whatever they want. And there's no logic. And they do lowercase and uppercase and everything uppercase and everything lowercase and only the first letter.
Yeah, because I couldn't find atrial fibrillation if one of it wasn't as stated.
So what you do is you say lower. So again, case sensitive. A concept code is case sensitive. So you can't say G with a lowercase g. I mean, it doesn't actually matter because read is not in there, turns out, anyway. But everything is case sensitive. The S, that's not S is a capital S and a capital C. Yeah, I'm sorry. It is what it is. So looks like people found out what the answer is. Who is still trying to figure out what these things are? Okay. Then pressing on. So the winners are 313217. And it's atrial fibrillation. We know that because that's the ICD-9 code. This G35 read code, if it were in the data, would have gotten you the same thing, 313217. It's just what read calls atrial fibrillation. And then, look, there is no ICD-10 code for atrial fibrillation. Okay? So ICD-9 and ICD-10 is not equivalent. Why did these people introduce a vocabulary that's not equivalent to the previous one? Because they could have just kept the previous one and not gone to ICD-10. So it's paroxysmal atrial fibrillation, which means the same thing. So the question is, now we got two standard concepts if I study atrial fibrillation. Okay? So okay, the class has to come back to order. Otherwise, we have to take students and put them in the corner for a timeout. And the teachers too, Rimma. Okay, Clair. We were trying to move on. All right. So look at this, right? So different coding systems will map to different things in SNOMED. That sucks. That kills all of the whole idea of having one way to represent this disease. Okay. So what do? We have an hierarchy, and the hierarchy is going to fix that problem for you. Done. The hierarchy is going to fix that problem for you. So here's the thing, right? People, particularly our friends in the statistics department, they assume that every disease is a feature and every disease has a code. Let's do later. And everything has a code. And if you have one code, you have one disease, and you have another code, you have another disease. And then they do the statistics about it, right? It's like a one-man, one-vote system, okay? That's not true. That's not how it works. The diseases are heavily connected to each other semantically, okay? So atrial fibrillation is a disease which is not completely different than paroxysmal atrial fibrillation here, okay? One is a sub-concept of the other. In fact, you could even claim in this particular case that atrial fibrillation in most cases is paroxysmal atrial fibrillation because it's not all the time. It only happens from time to time that the atrium does this fibrillation thing, and then it goes back to normal sinus rhythm. Sometimes it's all the time, and then you have a chronic or persistent atrial fibrillation. So that's what the difference here is. But again, these clinical concepts are not independent from each other. They are hierarchical. And so the vocabulary system actually gives you the hierarchy, and it will help you a lot. And you'll see that. Oh. And it'll help you with that. Okay. So these are the SNOMED concepts. And then there are relationships between them. Except this relationship is not called maps to, but is a or subsumes. Okay? So let's get all the relationships that atrial fibrillation, the SNOMED one, the SNOMED concept has, all the relationships. Okay? So what do? You query the concept relationship table and set the concept ID 1 to 313217. So concept ID is always the same, atrial fibrillation. And you get the results. These guys are what atrial fibrillation SNOMED code has a relationship to. And this is the kind of relationship that it has. So again, if you know all the 6 million concept codes, concept IDs, you're done. You know what this is, right? You know that this is subsumed. You know what this is, right? But you don't. So what do? We have to join the concept table so that we can actually resolve what these guys are. So let's do that. So so we ask the concept relationship, and we join the concept, and we want to know what concept ID 2 is, because 1 is atrial fibrillation, right? And then we set 1 to atrial fibrillation. So simple join for anybody who knows SQL, this is like rock bottom simple. And then you get the whole beauty. So now you see what the data has in store for atrial fibrillation. So again, these relationship IDs come from the concept relationship table, and everything to the right is the concept that represents the thing that atrial fibrillation has a relationship to, right? All the other guys. So now you can see, right? So you have our maps to. Here it is. There's a maps to relationship from 313217 to 313217. Because it already is a standard concept, and standard concepts map to themselves. So if you want to map a concept, you don't even care whether it's what it is, you just throw it into the concept relationship table. If it's already a standard, it'll just give it back to you. Okay? And then it's mapped from all these other guys, which are, as we've seen, here's mapped from ICD-9-CM. We did this in the exercise. From SNOMED again, of course. MESH, SEAL, ICD-10-CM, HIC, PICS. There's a HICS-PIC code. Patient with heart failure and atrial fibrillation documented to be in warfarin therapy. That's not a procedure, okay? This is a condition code that gets mapped to a condition because it says patient has atrial fibrillation, okay? We'll talk about this, the domain situation and how the concepts are assigned. So that's what this is. So the related concept is concept ID 2. And these are ancestor concepts. They're called is-A. Somehow we're missing a few pixels here. Is-A, not A, is-A. This gives you the parents, and subsumes gives you the children. Okay? So here's your persistent atrial fibrillation with a child, paroxysmal atrial fibrillation with a child. Okay? And the parents are fibrillation and atrial arrhythmia. So going back, fibrillation, atrial arrhythmia are the patients. Is-A, persistent and paroxysmal, subsumes. Okay? So you get the full hierarchy that SNOMED gives us and the other vocabularies in here as a concept relationship, just like MAPS 2. And then we have the ancestry relationships. And actually that's, a very elegant thing. And, you're going to use it much more than the concept relationship table. Because if you want to traverse this thing here, so you want to go from fibrillation to supraventricular arrhythmia, to cardiac arrhythmia, to heart disease, to cardiovascular disease, you're going to have to join and join and join and join. It's not only very slow, it's hard to type and it's awkward. And you can't easily query that thing. So what does the OHDSI system do in the OMOP vocabularies? It pre-calculates for you all higher level, second degree, third degree, fourth degree relationships. So it's going to have a record for parent-child, grandparent-child, great-grandparent-child, great-great-parent-child. They're all in there in the concept ancestor table. Okay? So these are all concepts. These are the concept relationships. These are ancestry relationships. And this is an ancestor. So instead of concept ID 1, concept ID 2, we now have ancestor and descendants. And we have levels of separation, which means how many steps are in between. And actually, the table has max and min. Max is the most, through your second degree cousin once removed. And the other one is the shortest path. The longest path and the shortest path. Usually, you only need the shortest path. Most cases. So this one has 2 levels of separation. 1, 2. That's a grandparent. Second degree. So let's figure this out. Let's try it out, right? So we query the concept ancestor table. Here you go. And we join it to the concept table for the same reason. Otherwise, we get these concept IDs back, and we don't know what the hell they are. So we always have to join the concept table so we know what's going on, what it is. And we hold the descendant, and we ask, what are the ancestors? What should we see? We should see supraventricular arrhythmia, fibrillation, cardiac arrhythmia, heart disease, all that stuff, right? So the whole hierarchical ladder. And if you do that, you do, right? So what do you get? Level of separation 0, that's me, myself. I have a 0 level of separation from myself. Parent, grandparent, here's your great-grandparent cardiac arrhythmia, cardiac finding, and so on. And somewhere here is the top dog, okay? Which in SNOMED is called clinical finding or something, I forgot what it is. You never need it because it's for analytical use cases, it's useless to ask for a clinical finding because that's everything. So, but that's funny because we get more than we thought, right? So we got the fibrillation and we got the atrial arrhythmia. And what the hell is this thing here? Well, it's a C, it's not an S. It's the classification concept. The hierarchy binds together in these relationships the classification concepts and the standard concepts, such that you can use the classification to query, right? In this case, again, it's a little silly because SNOMED already is hierarchical. But people use MEDRA if they're in the pharmaceutical industry or in the FDA. And if they're in neither one of these two organizations, they've never heard of MEDRA. They have no idea what the hell that is, and you can just forget it. But if you work there, then MEDRA is very warm and very close to your heart. So again, so for the purpose of what we're doing right now, only consider the S's, because that's what we're looking at, right? So this is me, my two parents, one grandparent, one great-grandparent, one great-great-grandparent, and so on, just like we have it here. Okay? It's a traversing the ISA hierarchy and sidesteps from one vocabulary to the other, because again, you can go between vocabularies for the hierarchy. It all pre-calculates it for you. Okay? Yes? Question?
You have a clinical trial population. You want to transition them to an observational cohort. And because of the regulatory requirements with the FDA, you have the measure codes. There might be some loss of information. How do you handle that? You know what I'm saying? You want to create the cohort. You don't want to lose information. You want to incorporate the measure codes, but you want the greater granularity that you would get from, let's say, the study database, and then transition all of that to the SNOMED.
Yeah, so the question is, if you have MEDRA and you want to go to SNOMED, in a way you then use MEDRA as a source code to do to SNOMED. You kind of can. There is a relationship which is called SNOMED to MEDRA, which is what the ancestor constructor uses in order to jump from one to the other. You can do that.
But there's a loss of information.
No, they're pretty equivalent. I mean, sometimes they may. No, not really. SNOMED is very, very detailed. So the loss of information, we're probably going to publish a whole paper on the whole loss thing. The things that you lose are usually attributes you don't need. So for example, ICD-10 has a whole lot of traumas, and they enumerate how you can get the trauma. You can be hit by a bicycle, you can be hit by a motorcycle, you can be hit by the car, you can be hit by a spacecraft. I don't know why they need that. I don't know how often that code is used. It's a very important code. You're going to lose data, okay? You lose that fact, because SNOMED doesn't care how you got hit. You got hit and you have a trauma, and you have like a skull fracture with a subarachnoidal bleeding or something. Okay, so yes, you lose, but actually you don't lose anything. Anyway, Chinua.
Hi, Chris. Just to clarify, suppose I have three concepts. A is the parent of B, B is the parent of C. Oh no, so
Yep.
A is the true child of B, B is the child of C. So how many relationships do you represent explicitly in your relationship table?
So the question is, what are the relationships that are represented here? So there are parent-child relationships, is A and subsumes. One is A is up, subsumes is down. It's the same thing. Then there are the ones which jump from one vocabulary to the other laterally. Yeah, if you go from SNOMED to MEDRA, that's why it's 0 here. So the reason I'm 0 here is because it's the same thing. So I did a sidestep. I went from SNOMED to MEDRA, nothing has changed. There's no hierarchical difference between the two. Okay? So even though it's a different concept, you haven't actually moved up and down. So that's your loss, right? So you're on the same level here. And so if you want to know exactly which relationships contribute to this hierarchy, there's a reference table called relationship, not concept relationship, just relationship, and has one record for each of the relationship ID, and it gives you a longer name, what it is, than these short forms, and it tells you whether it is hierarchical or not, so whether you do a step or not, and it tells you whether it goes into the hierarchy system or not. So the flags are called is hierarchical, that means granularity changes, and the other flag is called defines ancestry, I think that's what it's called, and then it goes into this, then the constructor picks it up. The constructor will go through the entire concept table, all the concepts, the relationships that have that flag, defines ancestry, and builds all possible trajectories, and dumps it into the concept ancestor table. So you can just blindly rely that it's all there, and you don't have to do your own search. You don't need to do anything. And that's why you're going to use it much more than the concept relationship table, because it's so much easier, right? Because you don't know how many steps are there, right? In the concept ancestor table, it doesn't care. It just gives you everything. And usually we order by levels of separation, but only because otherwise the database would give it, like in a family reunion, all generations are mixed. And if you order by level of separation, you get them nicely by generation. Praveen? So again, the question was different between min level and max level. Min level is the shortest path that you can find, and max level is the longest path that you can find. Usually they're the same, but SNOMED is so complex that you can have these long detours, and then you get this. Yeah, that happens. Okay, pressing on. So now let's do the same thing the other way around. So let's take cardiac arrhythmia and see what the children are, which means what are all the diseases and conditions which are cardiac arrhythmias, right? You're going to spend a lot of time on Wikipedia if you want to do this by hand. Or you have to read the medical textbook and remember it all. Some of us did that. And they remember something. Here it is. It's like a mini medical textbook for you in a database. So you hold the ancestor. This is cardiac arrhythmia. And you ask for the descendants, and you join them to the concept table so you know what the hell that is. Right? And so now we should get the same thing back, just the other way around, down. Right? So here you go. Max levels of separation, 0, that's me, cardiac arrhythmia. And wow, okay, a whole lot of children. And, premature beats, tachyarrhythmia, cardiac arrest is an arrhythmia because the heart stops beating, right? There are all sorts of things which not all of us would immediately think about this. Right, there is, I don't know, a nodal rhythm disorder. Did we change this picture, Mui? Where are my friends, the funny ones? Ectopic beats, ectopic rhythm, pacemaker twiddler syndrome. Who knows? Who knew what a pacemaker's twiddler syndrome is? Okay, it's a cardiac arrhythmia. So you're gonna realize what that means. You can query the data for all patients with cardiac arrhythmia. You don't have to know what they are. All you do is you take the children of cardiac arrhythmia and toss it at the condition table, and pull out all these patients. Okay, that's give me all patients with diabetes. What do? You find the diabetes, all the children, and voila, right? All patients with malignant disease. You find the top dog, which is malignant neoplasm. All the children thereof are all the malignancies. There are thousands. And you don't have to know them. You don't know that Hodgkin disease is a malignancy. Right? This is extremely powerful. It's not publication grade, right? So if you want a publication, you still want to go through these. And for example, the neonatal dysrhythmia, probably irrelevant to a study with Dabigatran, where probably the youngest patient is like 56. Okay, so if you really want to do a well-rounded and well-thought-through study, you're going to do manual work in order to check it out. And maybe there's even some missing that you would like to add. But for the quick and dirty, what's the size of my problem? How many patients of this kind even exist? This is all you need. This is all you need. And I blindly rely on it for most of those use cases, even though I could go in and try to do it myself, but that's crazy. Again, only level of separation 1. There are hundreds and hundreds which go into the lower levels. So the hierarchy is nice. There are two things. Hierarchy is nice, And the hierarchy helps you with the fact that the different coding systems have different levels of granularity, and they don't end up in different things. Now they end up in the same hierarchy, right? Both the atrial fibrillation and the paroxysmal atrial fibrillation is in the same hierarchy, and if you ask for atrial fibrillation and all their children, you get the ones which originally were ICD-10 codes. So you really don't have to care what the source code was, and was it mapped to the same SNOMED, was it not mapped to the same SNOMED? They're going to be in the same hierarchy if they're a little more granular than the others. And yes, ICD-10 tends to be more granular than ICD-9. Now, it also helps you to actually find your stuff. So we already did at the morning before, we found the concept by knowing the concept ID, the concept code, by knowing a concept code which is not standard and mapping it over, and by using the name, concept name, right? These were the methods that we used to find stuff. This is actually, the hierarchy actually going to help you, right? Because it's a very hierarchical system with lots of little detail, and it's going to help you. So let's find upper gastrointestinal bleeding. So what do? We get lucky again, upper gastrointestinal bleeding, select star from concept, where that's the concept name, bang, good, bad. It's a C. We need an S. So we can, of course, now take the hierarchy and go from the C and go to the S, right? And then you get a 2. But what we're going to try to do here is try to find, let's say we didn't find anything here at all, and nothing would come back. Why would nothing come back? Because there's a different spelling. They could call it hemorrhage rather than bleeding. And if you know that bleeding could be called hemorrhage, you also have to know that, you know, the codes, the concepts which come from British systems like Medra, spell it in the British way, so hemorrhage is spelled with an AE and not with an E, all that good stuff. And if you're in international situations, of course, then you have this thing in French. So what do? Let's find a standard concept that comes close, and then we use a hierarchy to move up and down till we find the one that we want. So the idea is find something. If it's too granular, go up. If it's too generic, go down. And the good thing about the hierarchy is you can't miss it. It's going to be step by step by step, and at some point you're going to have to hit the thing that you want. If you don't hit it, if you don't see it, you have to pick one of them. There is no more. The hierarchy will have everything that you need in there. Okay. So let's say just upper gastrointestinal, put it in wildcards here, so we're going to definitely find something. And then I want only conditions, so I don't get the measurement value again. And I only want standards. I only want standards, because that's what you're looking for. And so here's what we get. Stepping back a little. So you get disorder of upper gastrointestinal tract. That's good, but you know, we want bleeding, not just disorder, any disorder. We want the bleeding. Too general. Excessive upper gastrointestinal gas, no. Chronic upper gastrointestinal hemorrhage, that's good, but we don't want chronic, we want any chronic or, so again, too granular, right? Finding of upper gastrointestinal gas, not the one we want. Upper gastrointestinal hemorrhage, looks like that's the one we want. You see it's hemorrhage instead of bleeding, that's why we didn't find it here. Upper gastrointestinal hemorrhage associated with hypercoagulability state. That's actually what it really is, what we want, because you know hypercoagulability state means the blood is thinned. The coagulability is reduced. So let's say we didn't see that, because like it's so much eye powder here. We take this one, it's way too much detail. We say, we know that this is one of them. We want this one, but we want the other ones as well. What do? We toss it in the hierarchy, go up until we find the one that we want, right? So let's do that. Here you go. Hold the descendant and go up. This is the descendant with a hypercoagulability state. And so here it is. Here's our friend, right? This is me. My parent is already the one that I want. Again, here's Medra, so make sure that there's S here. We could add the S as a condition. The stupid C's would go away. But if you don't, then you have to just not pay attention. And again, MEDRA is a European system for some reason, and it's hemorrhage with an A. Same thing, we can go down. We can check out this upper gastric hemorrhage and see whether it really contains the conditions that we think it should contain. Or you go to a physician and say, is this the right thing? And they're saying, yeah, sounds like right. And say, can you check out the children whether the descendants are also right? Do you really want all those diseases? Again, hold the descendant, the ancestor, sorry, and check out the descendants. This is me, upper gastrointestinal hemorrhage. Duodenal hemorrhage, yes, it's a duodenum. Esophageal hemorrhage, yes. I can point with a microphone in my hand. Upper gastrointestinal hemorrhage, acute, yeah, acute is good. Peptic ulcer with hemorrhage, good. Chronic is good. Hematemesis means you're vomiting blood, yeah, it's good. You don't know where it is. It's somewhere in the upper gastrointestinal tract, good. All these guys are good, okay? Now you know, when you look at the children, that the patients you're going to pick up are the ones you want to see. No more lengthy code sets, okay, that go pages over pages over pages over pages, right? So people have like collections of malignant diseases in ICD-9. That thing is like 7 pages long in small font, right? No, you use the hierarchy of the system. Okay. Is what? We already on lunch? I'm getting it. You have to ask more questions. Exercise. Exercise. Please find the concept IDs for these conditions. Interestingly enough, the little database that you have, SynPath, contains plague patients. So I don't know. It is supposed to be modeled after a US CMS Medicaid patient population. And so that's what these patients have. So find them. You can use any way you want, right? You can just use keyword until you exhausted them. But if you want to do a little, useful exercise, then try to do the hierarchy. Find something where you know it's going to be in there, and then you move up, or something where you know it's a general category of that disease, and you go down. Just to get a feeling for what it means to go down. There are tools where you can browse up and down. We explicitly don't show you the tools yet, so you'll really learn how that works in SQL and how the database represents that stuff. But the tools do the same thing that we do here in SQL. There's no difference. But to understand the logic of how it works, it's really good to do it once, the hard way, the manual way. And again, we're going to be here to help.